Hi, good day everyone. Welcome to Transmission Media and Antenna System. I'm Kenneth Bergavera from AK31, College of Engineering and Technology at Universidad de Manila, and today, in this video, we're going to talk about plasma antenna guided by our professor, Engineer Brian Dineros. At the age of high-speed communication and cognitive radio, plasma antenna shine through in our current technology. Plasma antenna is a type of radio antenna that uses a medium to transmit and receive signal, but instead of traditional metallic material that receives signal, it uses partially or fully ionized gas as the conducting medium. In contrast of traditional metallic antenna, plasma antenna has many advantage properties, such as it can be rapidly switched off and on that can help to avoid hostile radar. Also, it can perform a fast switching of working frequency that are needed in mobile communication. Moreover, the plasma antenna is also resistant to an electronic warfare. Before we go further down on plasma antenna, let's define and know first the basic construction of plasma. Plasma is the fourth state of matter that discovered by Sir William Crookes in 1879. For instance, let's say that when ice is sufficiently heated, it melts from of water. It has therefore gone through a different state from solid to a liquid. We all know that when in the state of solid, the entirety of the particle is firmly packed in a fixed position, and subsequently has fixed shape and volume. The particles in a liquid are yet contacting each other and can move around each other. In this manner, a liquid actually has a fixed volume, however, it takes the states of their compartment. Water evaporates from a liquid to a gas. The particles in a gas are farther away from each other and take the shape and the volume of their holder. For specific substance, if you keep on applying heat to their vaporous structure, another difference in state could happen. This substance can go from a gas to a state matter called plasma. For this change of state to happen, very strong heat should be applied at the point when heat is sufficiently strong. The electrons are taken from their separate particles, making free electrons and positive ions. In despite of the fact that there are both negative and positive particles, generally speaking, plasma is a neutral as their equivalent measure of oppositely charged particles. Since there are free electrons, substance in the plasma structure can lead electricity. This is what separates gas from plasma. Gases cannot conduct electricity, but plasma can. Now that we know the identification and concept of plasma and where it came from, let's check comprehension. After the short comprehension about the previous slide and define the concept of plasma, let's now proceed and define the antenna. Antenna is a device that are connected to every radio. They are transducer that convert the voltage from transmitter into radio signal, and they pick radio signal out of the air and convert them into a voltage. For recovery in receiver, the antenna transmitter generates the radio wave. A voltage at the desired frequency is applied to the antenna. The voltage across the antenna elements and the current through them create the electric and magnetic waves. Respectively, at the receiver, the electromagnetic wave passing over the antenna induces a small voltage. Thus, the antenna becomes the signal source for the receiver input. Basic theory and plasma parameters. According to the study of plasma antenna, that in terms of electromagnetic properties, a plasma is a non-homogeneous, non-linear, and dispersive environment. Permeability, conductivity, and permittivity in plasma can be varied in terms of frequency and other parameters and make plasma a special environment. As a result, for any frequency of the incidence wave in any density of ionization, one particular response occurs. We can select if we want to absorb, scatter, or pass through by changing the basic parameters like electron density and collision frequency. The relative permittivity of a plasma is defined in these equations. The plasma frequency is a measure of the amount of ionization in the plasma. The operating frequency of the plasma antenna is the same as the operating frequency of a metal antenna. Plasma frequency is equal to the square root of 4 times pi times electronic density times charge of electron squared over electron mass. And electron density can be defined by using this equation. Also, the study said that the boundary condition at the electric vacuum interface are that the normal components of the displacement and tangential components of electrical field by continuous. These conditions are satisfied at the plasma or boundary. Satisfaction of the boundary condition gives the potential inside the plasma in terms of the incidence amplitude and frequency, and it's shown that the field in the plasma becomes large when the frequency is equal to the plasma frequency over the square root of 2. Since the plasma column is in resonance at the electrons in the column oscillate in response to driving electric field, this motion radiates or scatters the incident fields in cylindrical waves. Since the motion of the electrons in the plasma is largest at resonance, the scattered power will be maximum at resonance. In the matter of frequency is greater than plasma, frequency the propagation constant become imaginary and the wave will propagate. Nevertheless, if plasma frequency is greater, then the propagation constant become real and wave will not increase or propagate. Now that we know how antenna works and uses, we also understand the basic theory on how plasma antenna works. Let's check comprehensions. After the short comprehension about the previous slide, now let's proceed to know the advantage and disadvantage of using plasma antenna. The plasma antenna is a rising innovation that incompletely or completely use ionized gas as the directing medium rather than metal to make an antenna. A plasma antenna can be used for both transmission and reception. The vital favorable circumstances of plasma antenna are that they are exceptionally reconfigurable. The plasma antenna has many advantages over current conventional antennas, which make them suitable for military and commercial use. Advantage of plasma antenna such as invincible to radar, no ringing effect, more efficient, dynamically reconfigurable, fast transmission, low interference, high gain, wide bandwidth, and also resistant to electronic warfare. To every advantage, there are also a corresponding disadvantage such as complex design, more power consumption, always stable and repeatable plasma volumes are required, costs required for ionization plasma is more, and maintenance to repair or replace the unit components will be high. Now that we know the advantage and disadvantage of using plasma antenna, let's check comprehension. The application of plasma antenna can be used to radio and television broadcasting, space communication, military application, faster internet, and also public safety network. Here is the block diagram to understand more how plasma antenna work. To summarize, the rule behind the working of plasma antenna is same as the ordinary customary antenna. Just the solid metal transmitter is supplanted with a plasma. This plasma gives advantage of interest over the current antenna. It is more proficient, quick, and furthermore can be fabricated economically. There may be a few disadvantages related with plasma antenna, however, those can be overcome. It will require some investment for plasma antenna to be industrial accessible, yet it will change the scene of the antenna when it's accessible for use. This is the end of my video. Thank you for watching.